I'm Steve Reiser. I'm a professor at the University of Washington in Seattle, and I'm going to talk about the technology of floats that we're going to use in GO-BGC. The technology consists of the floats themselves and the sensors. I'm not going to say very much at all about the sensors because Yui Takeshita in the next talk is going to get into that in a very big way. So I'm going to talk more about how the floats themselves work. As with Ken, I'd like to acknowledge our sponsors, National Science Foundation in this project, and of course, NOAA and NASA in closely related projects as well. You can see on the left here, three different kinds of floats. The one labeled Argo Apex is a float that we typically use in Argo, core Argo. The BGC Apex is a similar version of that has been extended and used in BGC Argo and will be used in GO-BGC. You can see it has more sensors on the top. And then there's a BGC Navis that is even larger and has many of the same sensors. The two yellow floats here we get from Teledyne Web. We buy the components, we do the assembly checkout and calibration and add the code ourselves. The BGC Navis comes from Seabird Scientific, which is produced commercially and we buy. The yellow ones here, the BGC Apex, we build those in conjunction with Mbari and Ken Johnson's group, who builds the nitrate and pH sensors. The other thing is, I should say, is that this talk is very much a condensed version of the talk that's available on the GO-BGC site. There's an audio version of that with much more detail, and there's also all the slides are available on there as well. So Ken mentioned Argo. We couldn't be doing anything, most of the things we're doing right now without the history of Argo, which has allowed us to really, a lot of the technical developments that we depend on in GO-BGC came from Argo. I'll just briefly say that Argo's been going on now since 1998. There are 32 countries. It's global, including the sea ice zone. Importantly, the data are all available in real time. Skip down a little bit. Argo has been so successful that there are over 4,000 papers published that use Argo data since 1998. An amazing thing that has really added in a big way to ocean science. And in addition to that, there's over 300 PhD dissertations that have used Argo data as well. And Ken mentioned this, so I won't dwell on it, but one of the things we've gotten out of Argo, this is something put together by Susan Wafels, is you can actually, by global averaging the data going back to 2005, you can see the warming in the ocean, and the surface waters of the ocean since 2005 have warmed by about 0.2 of a degree, and the deep waters have warmed by something like 0.3, 0.4 of a degree. Sorry, 0.02 or 0.05 degrees. So the ocean has warmed and we can see it. And this has a tremendous implication to climate change and to climate models. And you can imagine that 20 years from now, we'll be able to do the same kind of thing that you see here with biogeochemical data like oxygen and nitrate and pH. We should be able to see acidification in a few years, very much like we can see the temperature change now. Ken showed a plot similar to this. This is 402 BGC Argo floats deployed by many countries from a few days ago. These do not all have 5 or 6 sensors. In fact, most of them don't have that. The BGC Argo recommendation are for 6 sensors: a CTD, oxygen, nitrate, fluorometer and backscatter, pH, and a radiometer. And not all of these floats have that. In fact, probably most of them don't. But you can see there in the Western Atlantic, the first 11 GO-BGC floats that were deployed 2 months ago have all of these sensors except radiometers, and they're working well. So GO-BGC is underway, and there are plans later this year to do several cruises in the Pacific to add more floats. And here are the floats that we actually will be using. Let's look at the two floats on the left here. The yellow one is the UW Mbari Apex float with BGC sensors, and you can see the sensors that are involved here: the pH, the nitrate, the CTD, oxygen, and then there's the satellite antenna, the iridium antenna, and on the bottom is the FLBB sensor. And we build these at UW from parts from Teledyne Web. Mbari builds many of the sensors. We expect to do about 40 of these per year throughout GO-BGC. The one on the left is a Seabird Scientific Navis float. It has many similar sensors. This is a commercial float, which we really need because we can't make enough floats in-house. We really need a commercial supplier, and that's what Seabird is doing here. These floats are different, but in the end, they do many of the same things, and that we're going to be deploying about 40 of those per year between the University of Washington and Woods Hole. The float on the right there is an NKE Provar used largely in Europe and some other countries. We don't use these much in the States, but they are a very good float. They've done a lot of good research, and the use of them will continue by many people. And as we get to 1,000 floats and the other 500, many of those will likely be NKE Provors. And then there's another float here, a new float we will be using in the US is the BGC Solo that is produced jointly by Scripps and MRV Corporation. As you can see, it looks something like the other floats. It has some advantages. It's a newer, updated design than the other ones, and we hope to be able to be deploying the first of those before the end of the year. Scripps will be doing that in the Equatorial Pacific. There's the first NCAP for one of those. Eventually, 10 to 20 of those per year throughout GO-BGC. I mentioned the first floats, GO-BGC floats. There you can see in the Atlantic, the red star is one of those. I just thought I'd show you what the data look like. So here you can see the profile. This is from Profile 5 from a week or so ago, and you can see nitrate, oxygen, temperature, salinity, fluorescence, and backscatter there. Profiles, there are discrete points, about 100 points in the vertical for the BGC variables. Temperature and salinity are binned at 2 meters, sampled at 1 hertz. There's also pH. I didn't show it on here, but we have perfectly good pH data from there as well at about 100 points. Most of these 100 points for these variables are concentrated near the sea surface. Here's how a float works. This is at least how an apex float works. There is a motor that drives a piston that pushes hydraulic fluid, that's oil, into a bladder. The bladder inflates, and that changes the buoyancy of the float. And you can see here on the right, there's the bladder uninflated. There are actually two, an air and an oil bladder together there. Then there's the oil only, about 260 milliliters, and then there's both air and oil. So that's what makes the float go up and down. And of course, there's the CTD unit. This is a Seabird 41CP CTD. This has been used on profiling floats since 1999 with some improvements, but the basic design hasn't changed, and it's very reliable. And most of what we have learned in Argo has come from this. I won't belabor this. You can see it in the extended talk, but this is how a CTD actually works. There's an intake, there's a biocide, there's a pump that works as the float is ascending, and it's essential to keep the interior of the CTD, this conductivity cell, clean in order to get good salinity data. But we've learned how to do this over the years. The energy budget for these floats, well, let's just say here that we've measured all the drains of energy in the lab, and we know that we take about 19.8 kilojoules per profile, and we know that we have 5,200 kilojoules in our batteries, so that leads to about 262 profiles. And that's consistent with what we've seen over the years. And in addition to that, we've found here that the BGC sensors themselves only require about a quarter, 25% of the energy available. So we're getting a good deal here with BGC. It's mostly the buoyancy pump that takes the energy here. Finally here, I'd like to say that here's some useful review papers. Each of these papers has a number of references about float technology that, for those of you who are interested, you can look these up and read them, and in addition to the papers that Ken mentioned. And finally, just a summary, BGC Argo is underway. This is an important part of, well, GO-BGC is an important part of BGC Argo, and that's an important part of One Argo, which is Core, Deep, and BGC Argo together. The technology has been developed over 20 years. It's now at a mature stage, but we've been doing this for a long time, so we know how to make these floats work. 500 in the next 5 years. We hope for 500 more from the rest of the world. There are 3 kinds of floats we're going to use in the US: Apex, Navis, and BGC Solo. And we expect to have all of our floats will have 5 sensors, and eventually we'll add a radiometer, so they'll all have 6 sensors. Thank you.